Stats class. So I'm going to show you how to use create a regression line and then use it for prediction. So the first thing I'm going to do here is I'm going to enter in all the data into my stat editor. So that's just stat enter. I got data in here. I'm going to clear it out. Just highlight the row. Press clear enter. Same thing. I'm going to go over to L2. Press up, clear, enter. All right, then I'm just going to go into L1, enter in all the X's. Go into L2, enter in all the Y's. All right, and then once I have that in there, I'm going to press stat, go over to test, and then press up to linreg test. I'm just going to enter. It's going to ask me where are my X's. It's in list 1. My Y's are in list 2. I don't have a direction implied when it says use this significance level. So I'm going to just say not equal to for row. And then I have my regression equation down here. I've got it set to go to y1, and to get that set up, you just press vars, scroll right to yvars, enter on function, and then enter on y1, unless you want it in y2, 3, 4, any of the others. But I just typically just default mine to y1. All right, and then go down to calculate. All right, so there is the test that they ran. This is my value for A, which is the first value, that's the constant. B is with the X, so that's the slope, and you can scroll down and get, there's that number. All right, it wants me to round these to one decimal place, so that's going to be a negative 330.4, and then for the number in front of X, that's again, the B is in front of X, so B is 16.3. All right, press enter there, and then it says, what's the best predicted weight for a bear with that chest size? Those are, chest sizes are our X's, so that's going to go in for X, and then we're being asked to find a Y. And we're either using this line or we're using the mean of the Y values. And what determines if we use the line is the p-value less than alpha. So there's alpha, 0.05. Our p-value is 2.9. You may look at that and say that's not bigger, or that's not smaller, but it's e negative 4. The 2.977, but e negative 4 means that decimal point is actually 4 places to the right, to the left, and that ends up being 0.000297. So it's in scientific notation. It's so small, the p-value, that they're writing in scientific notation. So when you see a p-value with an e to the negative 4, that means it's going to be smaller than any significance level that we choose. So what that means is I am going to use the regression line to come up with my estimations. Now, the easiest way, in my opinion, to do the regression line, once you have stored it in the calculator, is to go back to that vars menu, call on the functions, and call y1, and then you just use function notation. So which means I'm going to open a parentheses, put in the estimation, the 40, close that parentheses, and hit enter. And there's my estimation. All right, round to one decimal place, so that'll be 322.5. All right, hit enter. So there is my predicted value. If I wanted to just do the equation here, and then I would just put that in there, and then where the X is, times X, I would put times the 40 that I just put in here. So you could do it without using that Y1. Notice it gives a completely different number. And accepted that. So it's not expecting you to do this notation. It's expecting you to use this line right here, but it's got built in. If you were to be able to look behind the scenes, it accepts you doing what I just did here. If I started this problem over and chose to do this method, plugging directly into my previous answer, it would accept that, but it also accepts you using technology, which uses many more decimal places and thus gets a different answer when we plug 40 in. But it's perfectly fine to use either one. All right, the actual weight is 392 pounds. It wants to know if that's close. The way that we do that is we've done close calculations in here. Is it within 5% of the actual weight? So take the bigger of the two numbers. You don't have to take the bigger of the two. You just have to ignore the negative sign if you start with a smaller number. But I'm going to take the 392 because that's bigger. Subtract what my estimation was with this line, 321.6. And then I'm going to divide by the actual weight. All right, always divide by the actual. The actual is the 392. And then multiply that times 100. And you can see that's almost 18% difference. So these are not close. So the result is not very close to the actual weight of the bear. So that's option C there. Okay. So you're looking for that 5% threshold that we've been using all semester for close on a question like that.